today we're looking at our last conic section, which is a hyperbola. It is basically two parabolas that are facing opposite directions from one another. The definition of our hyperbola is very similar to our ellipse. So it is the set of all points whose difference of the distances to two fixed points is constant. So what's our only difference between this definition and our ellipse definition? Yes. So our ellipse said the sum of the distances. This one is the difference. So notice that here, my two fixed points are still my foci. So my D1 goes to my first foci, my D2 goes to my second foci. And if I subtract those, so D2 minus D1, I'm going to get the same number for any point along those curves. So remember, just like before, with our ellipse, we do have a center of the whole thing. We also have two vertices now this time. And we have two foci. So notice that C is still the distance from your center to your foci. And A is still going to be the distance from your center to each of your vertices. Now, you do have a different name. We have our transverse axis, which is basically this imaginary line that's going to go through all of those points. So it goes through your center, your vertices, and your foci. So if our transverse axis is horizontal, then my parabolas will open horizontal. If my transverse axis is vertical, they will open up and down instead. Questions on that? All right. So here are our two equations. Again, remember we have two because they are, one is for our horizontal, one is for our vertical. What's the biggest difference here between our ellipse? What do we have this time instead?
They're both square, both sides.
They were both squares for our ellipse too. There's subtraction now instead of addition. So this time A is not necessarily bigger than B. The way that we know if it's horizontal or if it's vertical is going to be whichever one is positive. So if our A value is positive, if our A value is with our X, if X is positive, our A value is with our Y, if Y is what's positive. The other big thing that we need, so we talked about that the the vertex is A units from the center. The foci are C units. And we have another equation that relates A, B, and C together for us. I mean, the last one was Pythagorean theorem as well that we used. They were just in a different order. Because remember, it's always leg squared plus leg squared equals hypotenuse squared. And last time, our A value was our hypotenuse, which is why it was the one that was by itself.
This time it's like correct.
It's the one that y'all are used to see, yes. There's not really a correct way to label your legs. Which is one of the reasons why in our last one, A had to be bigger than B, because A was your hypotenuse, and your hypotenuse always has to be your biggest value, correct? Whereas this time, A and B are both your legs, so it doesn't matter which one's bigger. Questions so far? So again, there's a lot of formulas. So our last set of formulas that we're going to learn for our conic sections are asymptotes of our hyperbolas. So your hyperbolas do have asymptotes. Your asymptotes are going to tell us how wide or narrow your parabolas are. So the steeper your slope of your asymptote, the wider that your parabolas are going to be. And again, we have two equations because we have one for our horizontal and then one for our vertical. Mm-hmm.
Is the graph on the left horizontal?
Yes. Alright. So let's look at an example. So this says, find the standard form of the equation of the hyperbola with foci at -1, 2, and 5, 2, and vertices at 0, 2, and 4, 2. So what do we say is generally helpful for us to do when we're dealing with our conic sections? So sketch a graph. Because it's going to help us kind of determine what our orientation is for our graph. So where are the foci located? So my first one is in which quadrant?
2.
The second one, okay. And then in what relation to my first one is my second foci. To the right. And then our first vertex is going to be on our y-axis. And our second one is going to be to the right of that. And which direction are my parabolas going to open? To the left and to the right. Because remember, the foci have to be inside of your parabola. So then, which of our variables do we want to come first? X or Y? X. So what are the 4 things that we need to know in order to be able to find our equation? A, B, H, and K. Do we know any of those right now? How do we find H and K? The center. How do I find my center?
Vertices.
It's going to be your midpoint formula. And remember, you could either do the midpoint of your 2 foci, or you could do the midpoint of your 2 vertices. Just don't do one of each. Does that make sense? Okay, so what would our center be in this case? So then what are our last 2 things to find? A and B. Do we know A or B?
We know A. Yeah. Or we can find A.
Yes, so A is our distance from
Vertex to the center.
the vertex to the center. So if my center is at 2, 2, and my vertex is at 0, 2, what is my A value? 2. So 2 squared gives us 4. Then what do I want to find? Do I need C for my equation?
No.
I need B. So what does that mean?
What is
B is going to be given to us by our asymptote. They don't give us anything about our asymptote. But we have to find C because then we can use our Pythagorean theorem.
that? So you have to use Pythagorean theorem to find B?
What?
So you need to use that to find B?
Most of the time. Depending on the information that it gives. If it gave us information about our asymptotes, then we would be able to use that information to find B, but this time it doesn't.
What information about the asymptotes?
The slope. Remember this one? B divided by A or A divided by B. So if we already have A, then we can find the slope and use that to find B. Alright. So it's C squared equals A squared plus B squared. What is C going to be? So remember, C is our distance from the center to the foci, so it's going to be 3. We already found A. So what is B squared? 5. And that's my equation. Now, is it alright that my A is smaller than my B? Yes. As long as our subtraction symbol is in front of our Y instead. Questions on how we found any of the values or where we plugged stuff into or anything like that? Yes, no, maybe? Alright. Looks like I got another one. we want to graph it. What do we need to do in order to be able to graph it? Write it in standard form. Now, what's my problem this time? Yeah, but how do we change that? So sometimes we have to complete the square, but we only have to complete the square is if we have stuff that has x's or y's. Right now, we only have x squareds and y squareds, so we actually don't have to complete the square.
So would you divide the 4 over 2 side?
Not quite.
You divide the 16.
You want to divide your 16. Because remember that we want our equation to equal 1. So we would have x squared divided by 4 minus y squared divided by 16 equal to 1. So what is your center?
0, 0.
What's your a value?
2, 4.
And your b value? So if I graph my center, then where are our vertices going to be? Not quite.
2, oh, okay. 2, 0.
2, 0, and negative 2, 0. Why did we choose to go left and right instead of up and down?
Because the x is first.
Because the x is first. Now, in order to be able to graph the rest of that, we need to know what our asymptotes are. Because our asymptotes determine how wide or narrow our graphs are going to be. So there are 2 ways we can do this. The first is just to use those formulas that I had on the previous page. And you would just write out the equation and then graph the line. Okay? The second, the one I prefer, and it's just the box method. So notice that my b value is 4. So I'm going to go up and down 4. And then I'm going to make a box that connects those points together. So they're kind of like what your co-vertices would be for your ellipse. And then I'm just going to draw a line that connects the corners and my center. And those are the asymptotes. And so remember, your asymptotes are going to tell us how wide or how narrow your graph needs to be. And you would get the same lines if you just plugged in all the information and found the equations and graphed the lines. But I think this is a little bit easier to remember than trying to simplify the not nice looking formula. So, questions? Are we all okay with how we found all of our information and how we got our graphs from it? Alright, let's look at another one then. So what are we going to have to do on this one? Yes, so on this one we will have to complete the square. So just like with our ellipses, my first step is to put my stuff that has x's together, my stuff that has y's together, and move our stuff that doesn't have either to the other side. So, will I have to complete the square with my y? No, because you're like before, I don't have anything with just a y, so we don't have to worry about it. Well, I have to complete it with my x, though.
Yes.
So what's my first step to complete the square with our x's? Can't divide by 4, but we can factor out of 4. Now, what's my formula to find what needs to go on the inside?
E over T for
Agreed. So remember, that's our completing the square formula. So what's our new b value for our x's? No, our b value is 2. So 2 divided by 2 is 1. 1 squared. That'll give us 1. So then what do I need to add to the other side? Not quite. So remember that this 4 applies to everything in the parentheses. So it's going to be a 4. So then remember, our whole goal in completing the square is to make it a perfect square. So we factor. What multiplies together to give me 1, that adds together to give me 2. It's 1, 1. If it doesn't factor to a perfect square, then you did something wrong. And then what do we have on the other side? Negative 12. So then what's our last step? Okay. So what's going to happen to our x stuff if I divide by a negative? It's going to become negative. And what's in the bottom? 3. And my y stuff is going to become positive. And it now equals 1. And then my last step is just to rewrite it so that our positive part comes first. So where is our center at? Almost. No. Negative 1, 0. Because remember, we have to flip the sign. And this time, since my y is first, what direction are we going to go for our vertices? Vertical or up and down? So again, we need to draw our other 2 points so we can draw our box, right? So we need to know our b value. What is our b value? It's going to be the square root of 3, which is what? As a decimal. It's 1 point something. What is it? 1 point. It's 1.7. So I'm going to go left and right 1.7 to put my other 2 points. And then again, remember, we're going to draw our box. And go through our corners. And then that's what tells us how wide or narrow our parabola needs to be. Are we all okay with that? Do we all see how we found all the numbers and such? No, which ones?
like the where you first deposited that.
Okay, so remember that it's going to be my h comma k is given to me by whatever's being added or subtracted to my x and my y. And remember that we have to flip the sign of whatever's on the inside. So my first number always goes with my x. So in this case, it's a positive one. Remember, we have to flip the sign, so we get negative 1. Then I don't have anything with my y, so then that's just a 0. So then it would be negative 1, comma 0.
So what about the other 2 points?
So remember that my a value is whatever underneath my y squared. So we take the square root, and that's how I got 2. And because it's underneath my y, that tells us that that's how far we're going to go up and down. And then our b value is whatever's underneath the other one. Again, we have to take the square root. The square root of 3 is like 1.7-ish. So then that's how far left and right we went to be able to draw our box.
Okay.
Does that make more sense?
Yeah.
Other questions? Alright, we have one last example. So this time they give us a graph and we need to find the equation. So our first one is we need to decide which equation am I going to use. Okay, which means which variable comes first. So we have y minus k squared divided by a squared minus x minus h squared divided by b squared. So again, what are the values that we need to find to plug in? A, B, H, and K. So 4 numbers. What ones might be easiest to find first? H and K. So remember that in this case we can find our HK kind of 2 different ways. One, it's going to have to be the midpoint of my 2 vertices. And then 2, it's also going to have to be the point at which my 2 asymptotes intersect. Now remember that all of my vertices and my center have to line up. So what does my x value have to be? 3. And then my y value is going to be halfway in between 1 and negative 5. So what would that be? Yes. But just realize that it might not always be super accurate. So just make sure that you verify that those numbers actually give you 3, negative 2. So then we can plug that in for H and K. Be careful because remember, which one of those is going to go with my y value? The 2, yes. Because even though my y comes first, it still gives me the y value for my center. And then I would have a minus x minus 3 squared. So then what are we left to find? A and B. Do we know A? Yeah, so remember A is going to be the distance from your center to the vertex. So how far does it take for me to get from 3, negative 2 to 3, negative 5? 3. So then I square it and we get 9. Are we all okay with that? Now this time, did they give us any information about our foci or our C value? No. But what did they give us? They give us our asymptotes. So this time, we don't have to find the equation of our asymptotes, but we do have to use those equations that we had on the previous page because we have to figure out what B is. So what was our equation for our asymptote? Y equals K plus or minus, and then the only difference is if which one we need, A over B or B over A. So we have a vertical hyperbola, right? So we want the A over B. Okay. Now, notice that if I plug in some of the information that I already know, this is negative 2. My A value we already found as 3. We would have that. Agreed? So what would be the slope of that equation? If we multiplied it out.
Oh, it would be like
So my slope ends up needing to be 2 because that's the equation that they gave us, right? So yes, this is my slope. Okay, but what's my slope here on this one? Or what's going to end up in front of my x? 3 divided by b, right? Do we all see that?
Yeah.
That if I were to multiply, this would end up in front of my x. Then this part would still just give me a number, but it's not going to have x's. And then 2 doesn't have an x. So the only thing that's going to be in front of the x is 3 divided by b. So that part has to be our slope. Are we all okay with that? Well, if I know that this is my slope, and I know that our slope has to equal 2, what can we do? 3b equals 2. Or 3 divided by b equals 2. So then how do we solve for that? Multiply by b, and then divide by 2. So we get that b equals 3/2. Are we all okay with my steps up until that? Because we need to be able to solve for b given our asymptote equation. Or solve for a if we were given information about b. So then what's going to go underneath my x? Not the square root, but the, right? So I would square both of those. But then, we're combining a lot of information here. If I have an improper fraction, complex fraction, what do I do to make it look a little bit nicer? Multiply by the reciprocal. It was in our rational review at the beginning of the year. You also should have learned it in Algebra 2.
I know, like when we were doing it with this stuff.
Now?
Oh.
So I'm multiplying by the reciprocal of the denominator. So my 4 is now going to be on top. And my 9 is what's going to be on bottom. And that would be my equation. Again, the hardest part for these problems is going to be like manipulating and using your different equations. From there, mostly you're just adding, subtracting, multiplying, and dividing. Yes? So, are you okay that this is the equation for our asymptote? Do you agree with me? Okay. And then that here, I just plugged in all the information that I know. Agreed? Okay. Now, if I were to multiply this out, right? Because usually we like things in slope-intercept form, right? Remember that our slope is going to be what's ever in front of our x, right? So notice that if I were to multiply this out, the only number that's going to be in front of an x is going to be this 3 divided by b. Does that make sense? So 3 divided by b ends up being my slope. Or the a divided by b ends up being my slope. Are we okay with that? So then notice that they gave us 2 equations. So on one, it doesn't matter which equation you pick. I picked the positive one, so that's why we picked the positive 3b. But if I know that this is my slope, and my slope ends up having to be 2, I can just set those equal to each other. Does that make sense? Okay.
So
And then we just solve.
it doesn't matter which one you put.
No, the only difference would have been is if I'd used the negative 2, we would have needed to use the negative 3 divided by b.
Okay.
Does that make sense?
How do we go from having 9 over 4 in the denominator to just having 9? Wouldn't you, if you multiply it by the reciprocal, wouldn't you have to multiply that by the 9? Like the bottom half?
no, I mean, technically here. If I multiply the top and the bottom by 4 9.
Oh, you. Oh.
Because this reduces to 1. It's just like simplifying fractions. So I mean the same thing like if I had 1/2 divided by 1/4, right? We change that to multiplication by flipping my denominator. Does that make sense?
But it would be like a fraction of fractions, like you would multiply the whole thing by 4/9, multiply by 4/9 over 4/9.
Correct. I mean, it depends on what way you want to think about it. You're either reducing or you're switching this entire division bar to multiplication. Either way, you're going to get the same thing.
Wouldn't you get 1 if you multiply?
On the bottom, yeah, and then you would do 9 times 1 gives us 9, and 4 times all of this stuff gives us 4. Does that make sense? Or, if you think about it this way, right, I changed my division bar to be multiplication, and then I had to flip this. So I didn't really multiply by anything. I changed my division to be multiplication. Does that make sense? Either way, you end up with the same thing. Alrighty, that's all she wrote.